SimplifIED are a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Hey, another day to try again. While we wait for the students to join us, today we'll be doing sine and cosine rules to be able to determine angles. So let me just invite some of the students in, and then we are good to go. Bum, 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 bum. Let me play that again. Bum, 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 bum.
SimplifIED are a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Hello, hello, hello. Hello.
Hello, sir.
How are you doing? How are you doing? Let me see. Oh,
I'm getting
already,
sick.
already spoke today.
Yes, I already spoke today.
Thinking one student asked me to do some trigonometry nyana. So I just felt like if I can add anyone who's gonna benefit from it, it ends up being something. And if there's one thing,
Mm.
um,
Hello.
hello, 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 Kumo, welcome, welcome, and welcome Naledi. And we're just waiting for one more person to join us if they're joining, because they said they might not be available. But anyway, um, trigonometry is what we are focusing on. Like I said, one student asked we should do some topics regarding trigonometry. So I felt like let's just make it about everyone because it's already that time you're past 7 to 8. If I was to go 1-1, I'm gonna limit myself to feel like let me do 30 minutes or 25 minutes in order to next to the next party. I'm like, you know what? Let's just do the trigonometric lesson, which everyone is gonna learn anything because I'm gonna generalize it anyway. Why
Mm-hmm.
do I say I'm gonna generalize it? I'm gonna generalize it because in most cases, when we deal with trigonometric identities in a triangle, we are used to have a right angle triangle most of the time. So I've realized that every
Yes.
time we every time we're dealing with our trigonometric identities, whenever there's a triangle involved, we always, or that's how we've been coming from the past, from grade 10, grade 9, we always know when there's angle theta, and I have to talk about sine, cos, or tan, there has to be a right angle triangle. And it's always about the adjacent and the hypotenuse. And then sometimes you ask yourself, what about the other triangles? Should it happen to have other triangles? How do we then find angles or find sides relatively so the way it is done with the right angle triangle? So let's break it down where it all starts, because we have different types of triangles. Anyway, I remember at some point in primary school, they used to teach you guys how to memorize the names of triangles. And some of you, like, there are some which you cannot forget, like acute and obtuse, right?
Yes.
You
Yes.
can't really forget acute and obtuse because it's just the other one is below 90, the other one is perhaps above 90, but less than 360 perhaps. But the whole concept of angles, they are just rotating things, and we measure angles using this protractor. So all the rotation of the angles is around this thing. We know 180, 360 when it's full. That circle is not a problem. The main issue is, in most cases, we always have it like this, which we are about to end it today. In most cases, we always have it like this. We know that whenever an angle is involved, we would have a right angle triangle. And if we have a right angle triangle, whether the triangle is like this or the triangle is like this, it doesn't really matter, because we know it would be 90 there, it would be 90 there. In terms of the angles, we know that if this happened to be theta, that's when we'd say this would be y, this would be x, this would be r. Same applies on the other side. If this happens to be theta, we say this would be y, this would be x, and this would be r. And from all this, we can determine any other angle that we want. Because, for instance, if theta happens to be 30, and we know this is 90, we know that this automatically becomes 60, because we know the story of angles on a triangle. So in most cases, regardless of what event we have, on a right angle triangle, we always know one angle is going to be 90 degrees by default. So we already have one angle inside. It doesn't matter with the other angles. And we know that from this, we can play around, because it's a right angle triangle. That thing sine theta is opposite over hypotenuse, which happens to be y over r, only happens when you have a right angle triangle. That thing of saying cos theta is equals to adjacent over hypotenuse, which is equals to x over y. This is only applicable on a right angle triangle. When we say tan theta is opposite over adjacent, which is equals to y over x, this again is only applicable only on right angle triangle. So this information is limited only on right angle triangle. So all this applicable, including Pythagoras theorem, r squared is equals to x squared plus y squared. Including Pythagoras theorem, we only apply Pythagoras theorem when there's a right angle triangle. So right angle triangle, Pythagoras theorem, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, how we play around with our identities. This one only limits us for a case of right angle triangle. Now, what happens when you have a random triangle G that is no longer a right angle triangle? doesn't have 90 degrees anymore. And then you somehow don't know all the angles. Suppose you only know one angle, which could be 20 degrees, whatever value it may be, and then we call this triangle A, B, C. And then from triangle ABC, we somehow know this would be side number. Suppose we know this is 3 units, this is 5 units. That's the only information we have. And in reality, we may have to determine the value of angle alpha or the value of angle beta, whichever. If we can know at least one of the angles, we would know all, because angles in a triangle are 180. But given that none of the angles are equal, and then maybe we have to get side A. Now, in this regard, we cannot use any of the applications that we use on right angle triangle. Is there anyone who know how can we approach this part?
So do we use the sine rule?
So we use the sine rule. So we have the new thing now, which is called the sine rule. Very simple rule. Very, very, very simple rule. So the sine rule says that if you have a triangle that is not equal, and then we can call this triangle A, B, C, such that if this is angle A, the side opposite to angle A will be side A, small letter A. If this is angle B, the side opposite to angle B will be small letter B. If this is angle C, the side opposite to angle C will be small letter C. Now, what does the sine rule states? Okay, this one was a question for the suggested sine rule. It was you, Kanya, who suggested the sine rule, ne?
Yes.
How does it apply?
Like, should I explain like the formula?
Yeah, from here, from what I have here, using this image.
Okay. How do I explain it? I can't explain it.
So this is how you explain it, ne? Sine of this angle is equal to this side. And sine of this angle will be equals to its opposite side. And sine of this angle will be equals to this opposite side. So when we put it in writing, we say sine of angle B, which is this angle, sine of angle B all over, or let me start from A to make the order. Sine of angle A all over side A. So the sine of this angle all over its opposite should be equals to the sine of any other angle. If we choose C, the sine of angle C all over its opposite, which is C. And it goes as far as this should also be equals to, furthermore, this should be equals to sine of angle B over its opposite. So I just didn't want to go with the order. I could have went A, B, C. So I went A, C, B. But it's the same. It doesn't matter how you put it. It should. The sine rule states that angle as it is, that angle, and so sine of this, we call it the sine rule because it is made out of sine only. So sine rule states that sine of this angle over that side is equals to sine of this angle over this side, which is equals to sine of this angle over this side. So it doesn't matter which order it goes to. This formula doesn't go in a pair of three. No, I don't want you to memorize as if it goes in a pair of threes all the time. Sometimes you may end up using this and this because the question needed you to use this to get the side. Sometimes you may use this part and this part only to reference this part only because the question needed you to get that part and that part. And sometimes you may combine this and that only to make sure you are following the sequence of what you want to get, depending on what side you have and what angle you have. Now, throughout this, it is what you'll be able to understand. It's just that you know that in a triangle, where I don't have a right angle triangle, and I need to determine either in angles or sides. Given that I'm given either angles or sides, then I will apply the sine rule. And then the sine rule is by definition for side A over A is equal to side C over C, which is equal to side B over B. And the denominator of the angle that you relate to sine is the angle, is the side opposite to that angle. So sine A over its opposite side is equals to sine C over its opposite side, which is equals to sine B over its opposite side. When you write your exam, the formula sheet, you have this formula, but they didn't put this formula in terms of a triangle like this. It is your responsibility to know how it works in terms of when you are applying it in a triangle, because it can be tricky if you use it wrong. So, with this regard, suppose we want to determine beta, angle beta. Just for an example, if we had to determine the value of angle beta at this side. Before I determine angle beta, I'm gonna use this scenario to write this rule in terms of this. From here, I have to choose the sides that matters based on angle beta. So since angle beta is connected to angle to B, to the value of B, I will say, okay, let me just use the color green for maintenance. So I would say sine of beta over what? Over 3. Because I'm applying the sine rule. Sine of this angle over its opposite, which is 3. It's equals to, and then this time around, I can't choose sine C because I don't know C. I'm trying to calculate the angle beta. Then I will choose angle A because I have the value of it. So this would be equals to sine of 20 degrees all over the side opposite to it. The side opposite to it, which is 5. Before I proceed, does everyone understand so far?
Yes.
Yes.
Great. So that's how we apply our rule for now. So from that, obviously to solve for beta now, that's where the maths comes in. Don't fall for it. It's not as tricky. It's the very same way as when we were solving any other angle. As long as you are calculating your angle, you know where your goal is to have something like that for the values of the thing. So don't rush it. Allow the math to work out in your advantage. So since you are solving beta and you have sine beta, it means then you may have to cross multiply this by that and this by that, because the goal is to make beta subject of the formula. And then if you cross multiply, you would then have 5 sine beta is equals to 3 sine 20 degrees. That's when I've just multiplied the 3 that side. That part I think will still all together. Therefore, this means sine beta, I'm going to divide by 5 both sides. I think I might have to remove this. So dividing by 5 here, dividing by 5 here, this will cancel that. Therefore, sine beta is equals to 3 sine 20 degrees over 5. I'm avoiding to simplify that part, although I know I could with a calculator. I'm saving it for this moment because beta is going to be sine of that minus of 3 sine 20x over 5. For now, since we are just looking for the value, I can remove this part just for the sake of space. We already spoke about it, we understand it. Or I can just move it below. I don't have to play around with the color, just to know that sine A over A is equals to sine B over B, which is equals to sine C over C. That's just the sine rule. So now, the beauty of a calculator, I just want to see what do you get for sine beta. I mean for beta, not sine beta. Beta is the angle. I made this question up, so don't worry with the size of the angle. Even if it's very small, it's fine, because I made this question up, so it's not accurate.
11,84.
11,84. Do we get the same, everyone? I get a different one. I
I
get
got the same
17.
one.
11, that.
Yes.
Why do I get, or maybe it's my calculator. Is everyone getting the same one?
Yes.
Yeah. 11,84. Yes. I think it was my calculation that was in here. 11,84. So with this one, you are not finding a general solution. You are finding the angle, which is just the reference angle. So you leave it like that. So meaning alpha would be 11.85. If you know the value of alpha, then you can know the value of beta. And then you can tell whether this diagram is not accurate, because how can the two angles be so small and this one be so big? Because for us to make 306, it means this should have been an obtuse. But that's just, like I say, this example is not accurate because I selected the question because I just wanted to talk about the rule itself. But anyway, let's take a moment and ask ourselves, does this rule make sense?
Yes.
Yes.
Besides the sine rule, have you ever heard of the cosine rule?
No.
Yes.
I only heard of the same one.
Some yes, some no. For those who have heard of the cosine rule, when do we use the sine rule and when do we use the cosine rule? Are there special triangles that are made for cosine rule? And are there special triangles that are made for the sine rule? That's the question I'm asking. Given that you are allowed to be wrong.
Don't you use the cosine rule when you're given all three sides, or when you're given two sides and an angle?
So it depends on what you are given. It doesn't matter the shape of the triangle, right?
Yes.
Sure. That's what I wanted to. Because look, the reason why I'm emphasizing on this, let me open this. I'll show you now. I just want to open a random past paper for whatever grade it may be, just random. We're going to go to that part of the formula sheet. Hey, sorry about that. My network was just humbling me for a moment. I don't even think it's the network, it's just this PC probably. Uh, oops. For some reason, it's taking me long to get what I'm looking for, but one more last minute. If I don't get it within the next minute, it's fine. I'll proceed to whatever. Okay, so now, yes, now when we look at this will be given to you when you write probably on your final. This will be given to you. So from this, you have, oh no, I opened the wrong one. Oh, no, 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 it's the correct one. So from this, you have this. This information is given to you, but they don't state the type of a triangle you have. You will find this information in your formula sheet. Or let me also count the third one, but the third one is now when you are finding the area, when you have an angle. It's the interesting one. The third one will be the last that we do. I don't think we're going to cover the third one today. The third one was just about the sine and the cosine rule, but we're still going to come to that given that we'll have to calculate the area. But it's applicably the same. If you can understand the sine rule or the cosine rule, it's going to be the other way around. Now, aren't you curious why my cosine rule is a bit different from the one that is given here? Remember, mine was the same as sine A over A is equals to sine B over B, which is equals to sine C over C. Isn't it concerning that the one they provided in the formula sheet is a bit different from the one that I gave when we were doing the thing on the other side? Because I said, yeah, I really, how do I do this? Oh yeah, I showed this. I wanted to share this without canceling what I have on the screen. So I showed you guys this. And now, since I showed you this, now these guys are coming up with another one now. They're saying this. And then any suggestion, who's wrong here?
No one's wrong.
No one is wrong, man. Because when you cross multiply, you can prove it yourself. When you cross multiply, if you have sine A over A is equals to sine B over B. If we were to cross multiply this, you would end up having B sine A is equals to A sine B. Also, you can write it the other way around and say A over sine A is equals to B over sine B. When you cross multiply, it's going to be the same thing. B sine A over B over A sine B. So all I'm saying is, for the fact that they are just fractions, whether you put it the other way around or the other way around, it's always going to be equal, because as long as the sides are aligned, so the angle with its opposite side, the angle with its opposite side. So now, while we are still here again, let's consider now the triangle they are talking about. So in the triangle they are talking about, we're going to construct our own triangle based on this same similar one. There is our triangle which doesn't normally have equal sides, and then it's triangle A, B, C. And then this is triangle A, B, C, and then we have side A, side B, and side C. So besides the sine rule, according to the cosine rule, so here is the cosine rule. The cosine rule is mainly about sides. When you have sides and at least one angle. So in order to calculate, if I have side B and C and angle A, and I need to calculate side A, I then would say A squared, side A squared is equals to the sum of the square of the two sides. Let me use a different color for that. So A squared is equals to the sum of the square of the other side, which would be B squared plus C squared. That part only looks like Pythagoras. Do you see it? But
Yes.
because it is not a right angle triangle, to make it up for it, and then you have to subtract 2 multiplied by the very same sides that you squared, multiply the product of that. And then clearly, when you are doing that, it means you also have the angle of the side you are calculating, which is the angle of A. So you must also have cos of that angle of A. So the opposite angle should be the one that is determined in the beginning of the side. This is how you use your cosine rule. Does it make sense?
Yes.
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 If we are to put it in practical, we can think of an ideal scenario where now we have (25°). And in most cases, for us to use the cosine rule, would be given maybe this side to be 3 units again, and this side to be 5 units. And then we have to find AC. So we know that CB is equals to 3, AB is equals to 5. I'm just going back to AB and BC to make you comfortable with the AB and the BC, although we are applying it using the cosine rule. So stick in your mind, stick to this part. We are still applying the very same rule, this one. I'm just gonna use AB, CB, and the angle, but in relation to that. So I have to calculate AC. So that's when I would say AC squared is gonna be equals to the square of the other side. So here's my AC, the square of the other side. So it's gonna be CB squared plus AB squared minus 2 times CB times AB cos of 25°. That's how I apply it. Definitely like that. We are still catching up together, ne?
Yes.
Yes.
Then from
Yes.
here, this will then be CB is 3 squared plus AB is 5 squared minus 2 times 3. I can even multiply it inside there. 2 times 3 times 5 then cos of 25. That would give you the side AC. So now, this part is not only limited in mathematics. What we are learning regarding the sine rule and the cosine rule, and also the Pythagoras theorem part, because now it's 3 types of calculating angles on triangles. The very same part, we're gonna use it in physics as well when we are working with other diagrams in the other side. So anything that regards trigonometry, you know, it works almost everywhere mathematically. But otherwise, while we are still here, let's just calculate that part to see if we're gonna get the same answer. The answer is not gonna be accurate anyway, again, because I created this question from my head. So let's just hope it works out. For that side, I get 6.81. Is it the same for everyone? 6.81 units. For AC. But that's how
Yes,
you
I'm
end
also
up.
getting that.
Yes, I
Getting the
also
same.
got that.
Perfect.
Yeah, I also
But
got it.
all in all, perfect. But all in all, it's just to be comfortable in knowing this. So let's now summarize our findings in terms of when do I use which one, when do I use which one, because it doesn't matter the shape of the triangle. As long as the triangle is not 90 degrees, because when the triangle is 90 degrees, that's when we have a right angle triangle. So when the triangle is less than 90, we have an acute triangle. So, okay, so these are the scenarios that we have. We have this, or but sometimes even that acute triangle can end up being a right angle triangle. So let me not just call it acute. Let me just, as long as the different size, doesn't matter. So let's not put naming, because also an isosceles can be right angle sometimes it cannot be. So let's not limit ourselves in terms of the shape of the triangle. Let's just say, as long as the angle is not right angle triangle, we'll use sine rule or cos rule. You can see that sine rule is applicable when we have 2 sides and 1 angle. But also, cosine rule is applicable when we have 2 sides and 1 angle. So for whichever scenario that you use, for you to use the cosine rule, with the cosine rule, everything must be aligned. With the cosine rule, from your A, B, C, your cosine rule requires you to have this angle as well as this side in order to determine this side. But the sine rule, it doesn't matter which scenario. The sine rule is saying you can have this angle, and then you have this side, and then you have this side. It doesn't correspond in this triangle here. You can't apply the cosine rule unless you know this angle at least in order to determine that side. Do you see where I'm going with this?
Yes.
Yes, because the cosine rule requires you to have, it requires the middle angle to be the one that is building the sides, and you are calculating the side opposite to that one angle. So it only requires one angle only. But side doesn't matter. If you have this side and you have that, you can get this side just by saying this to that, and then you're gonna take you might end up having to find this angle first in order to determine that side. But never mind the story. Let me bring it to reality. Let me look for a question that relates to what we are saying. Let me look for something in relation. Just give it a second. so many apps such that this is the perfect scenario of what you should expect. In the diagram below, oh no, in the diagram, I'm so used. So in the diagram, angle P is 57 degrees. PQ is given as 3 centimeters and PR is 9.6 centimeters. Determine the length of QR. Which one is the best rule to use here?
Cosine rule.
Cosine rule. Will sine rule work as well?
No.
It won't work because cosine rule, if we wanna use the sine rule, it would be only if they wanted angles in this regard. So another hint, as much as the sine rule gets both sides and both angles, for you to get a side on sine rule, you need at least 2 angles. For you to get an angle, you need at least 2 sides and 1 angle. So here, the best one to use would be a cosine rule. So that's when I would say QR squared, which is this, is equals to the square of the other sides, which is QP squared plus PR squared. I think I was wrong when I said the angle must be, oh no, I wasn't, because it is about that. The angle that we are looking for is opposite the side we are looking for. So from here, this is gonna be minus 2 QP times PR cos P. That's how I create my formula for QR. As long as you understand this part, then you are winning. We are still together on this part, ne?
Yes.
Yes.
Therefore,
Yes.
sure. Therefore, QR squared is gonna be QP is 3 centimeters squared plus PR is 9.2 squared minus 2 into 3 times 9.2 close bracket cos of 67 degrees. Therefore, this is going to be, you can simplify it to 1, or you can just punch it from there, because I mean, it's just numbers only on the other side, and we have enough technology got 2026 to solve this.
72.7. 0.07.
72.77. Does everyone guess the same? Let me just confirm also.
0.07.
0.07. Ne?
Yes.
72.07. I get the same. 72.07. So even if we wanted to use the sine rule on this one, it would be a challenge. For you to manipulate it, if you wanted to use the sine rule, it's no longer going to worth the 3 marks anymore, because you have to at least get one angle first in order to get QR. So I'm just saying, suppose when on that morning of an exam or on that day, your application for cosine rule is a bit off, because there are those people who would say, I happen to have mastered the sine rule than the cosine rule. It's fine. You just have to find at least one angle and then use it again to find the sine. Let's try it and see if it works. If it doesn't work, we cancel it from here. If it works, we know it's gonna work for one student out there, because the sine rule, once you master it, you can use it as faster as you can. So in terms of this, I could say targeting no. It's not gonna work. Like, I do want to try to manipulate it, but I have to end up saying sine of 67 over QR must be equals to sine of whatever angle that I already have, which could be R or Q, all over whatever side that I already have. But it was not going to work. But now that I know what QR is, since it's 72.07, that's when I can find any other angle that I'm looking for between Q and R using the sine rule now. So if you have two angles, you can determine the side. If you have two angles and one side, you can decide, you can use the sine rule to determine the side. But in most cases, when you have a lot of sides with less angles, rather we focus on the cosine rule. But otherwise, when time is right, after practicing these things 2, 3, 4, 5 times, and you are comfortable, then your guts will adapt to know when do I use the sine rule, when do I use the cosine rule. So now let's keep that in mind. Now that I know how to apply the sine rule, now that I know how to apply the cosine rule, when do I use it? When do I not use it? When do I use the other one? But otherwise, this is what the trigonometric part of other triangles regarding finding angles or sides of a triangle if you don't have a right angle triangle. And then from here, you just take this, you fly with this, because it's going to be applicable until you get to university or until you are done with mathematics in terms of finding the sides and angles of triangles. So now you are not depending on right angle triangle only. You are able to find the sides throughout everything. I have more to say, but for now, yeah, I have more to say, but for now it's fine. We can continue from here, because this question, once I explain, if I can open this question that I have here, it might require me another hour, and I'm trying to buy time to say, yeah, it might require me another hour. I'm trying to buy time to say, after this one, I think there's one of you who has this something regarding tomorrow. So I just want to focus on that, Hori. It should be fair for someone to at least cover whatever they have to face tomorrow. But before I cover that, if I can finish whatever I'm covering fast, if any of you has another question, I'm gonna still talk to you. But at least by 9:45, I should be done. I should knock off, because I've been working since during the day. Like, actually, I've been working since 11:30 today. Yeah. Although I ended up postponing for some of our lessons, but I started working and sitting here since 11:30. So it's like, as much as we go to school, as much as you guys go to school, Lina, I sit here like I'm in a form of a system that forces me to sit here until the thing. So Lina, when you can't wait for school to go out, a dog, Linda, sometimes I can't wait for 9:30, or like roughly just after 9:30, because I'm like, ooh, at least I can watch TV and just relax and not have to talk. It's fun at first when you start, but sometimes when you talk for the whole day, towards the end of the day, you feel like, yo, talking. That's why I make this final group lesson to be my last one of the day, because I know that sometimes we get tired. But I still keep in mind, we still have those students whom we know when things are busy, we keep each other awake until 12 a.m., 1 a.m. But until we get there, let's enjoy knocking off early if we can. Otherwise, thank you for your time. If you have any more questions, WhatsApp, just send your WhatsApp. If you have anything you want me to show you before you sleep, that is an emergency, send you a WhatsApp, but I know there's one student I must rush in between this group where I should show them something before we sleep. You can log out, guys. I will tell you how WhatsApp privately. Thank you for your time. Enjoy the rest of your evening and good luck with school tomorrow. Cheers. Bye.
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 Sure. You know the rule. You just log off. I mean, now I'm in charge here. Ke ga ka mona. All right. For those who are watching from YouTube, if you want to join our private lessons, it's easy. You just WhatsApp hello to 081 465 2676, or just WhatsApp lesson. Hello, we made it up wanting to talk. WhatsApp lesson. So whether it's mathematics or physics, just WhatsApp lesson to 081 465 2676. That's 081 465 2676. We offer our private lessons at a very reasonable fee, whereby we don't charge hourly. We have a monthly fixed fee where we just learn regularly throughout the time. We attend to students on one-on-one basis, as well as small groups here and there, but we maintain the whole CAPS curriculum until the end of the year. So we hold their hand through every test that they write throughout the year, every challenge they face, every assignment. We've got them, because we simplify everything for everyone, because that's what we do. Everyone needs to pass. Everyone needs to understand. If not simplified, then you might end up repeating a grade, and that's not what we want to do while we are here. Because if we are here, we are
SimplifIED, Aurus are the guys who makes it looks easy. Your number one learning